But let's kick off the conference.
Absolutely.
We will first hear about recycling, which is really, really interesting. That I have to say that because I work for him. So give it up for my boss, Rudolf Lawyer, talking about recycling fabric.
Good morning. I'm totally flashed. So amazing people at this place, amazing workshops, amazing speakers, amazing topics, and now I'm talking about something not that amazing, waste. Let's talk about waste and 3D printing. I think now it's working. Yes. Perfect. Let's talk about waste in 3D printing and the huge problem with it. The materials we are using in 3D printing are often not recycled and went through landfill or getting burned. And 5 years ago, 2 of my colleagues and myself, we discovered this big problem. And we thought there should be a different option, a solution for this high quality materials we are using in our 3D printers. Now we are around 15 people. Not all of them are on this slide. One of them is Janos as well, but he is doing a great job and connecting people. And people are the thing 3D printing is also connecting. When we look at our problem from the beginning, waste and recycling, it's not a circular system. It's a linear process where someone is creating something, then it's used, and in the end, it's maybe a bin, you open it, you put it in, then it's closed and out of your mind. So, not your problem. Someone else should do the rest. But in this system, we are losing precious resources we can use multiple times because the properties of the material are good for recycling. And these materials are often not that high amount for conventional recycling systems. And that's a big problem because they are expensive or difficult to source, or you can use it multiple times. Our resources on Earth are endless. Some days ago, Germany spent all resources for this year, and now it's the Earth Overshoot Day, it's gone. We are using more and more. So for a really circular economy, you need certain requirements. For example, good waste streams. There are waste streams that are mixed up with other waste streams, but why? Why are we mixing good materials with other materials? We can start early in the process collecting materials for recycling and manufacture this material into something new. And it's also, recycling is at the end. You know the 3 R's, reduce, reuse, and then it's recycling at the end, and also the reduction of the materials we need. Even in development of materials or prototypes, do I need to print the whole prototype, or could I print just little pieces of my prototype for each iteration? And also, it's a picture from yesterday. Jonathan sent me. He is recycling his own waste and is printing the infill of his prints with his recycled material. So he reduces also the carbon footprint of his own prints by using the recycled material as the infill and just a new material for the outer shell. So we also have to think about the carbon footprint. How much is my carbon footprint in 3D printing and when developing something new? Also, there are more and more possibilities for reuse and repair in 3D printing, like new software possibilities with AI-generated tools. On the last exhibition, I met a company that is scanning parts that are broken from 3D printing, and they can print on the broken surface to repair a part. So they don't have to print the whole part again. And of course, the recycling. This is where we took place. But when we think about recycling, there are also different options. From desktop extruders, you may know, or some of you tested them already. There are small machines you can put on your desk or next to your desk for small amounts of waste. And yeah, it takes a long time to produce something nearly printable, I will say. But you have something in mind. When you are buying a desktop extrusion line or a machine, the machine itself also has a carbon footprint. It's made of steel or aluminum materials with high carbon footprint. So you have to think about, is it possible to compensate the carbon footprint with the amount of material I will recycle in the future or not? So does it make sense to buy such a machine? Or is it more important or more suitable for development of materials or colors? So it's slow and ineffective and not usable with a high amount of waste. Then most of us know precious plastic, where you can recycle waste into something new. It's good, and it's suitable for regions where you can't build such big factories for recycling with high standards or high quality materials where you don't need it. But the problem is that it's not really circular. You're putting something material in new products and they are gone. Most of them are not coming back, so it's also a linear process. And then we have the videos on Instagram or TikTok, you may know, with the silicone molds. Something is putting in their oven with a poop inside to mold the next skull as decoration. I don't know how many skulls we need. You may know. I don't know. And then we have the industrial scale of recycling plastics. There are the conventional waste streams. They take care of the most common materials like PP, HDPE, and so on. And then we have the really precious, low amount materials we take care about, like PLA or PETG. I show you our recycling cycle where we collect the waste directly from customers or users that are using 3D printing. That means private persons, companies, schools, universities, everyone who is using 3D printing. In the beginning, we thought about it. It should be as easy as possible to put material into a circular system and not difficult and you don't have to pay and so on. And then we are doing the rest. We take care of the material. We are sorting, shredding, we prepare the material to have high-grade granulate for our extrusion lines. So we do granulate, and then we can do our 3D printing filament out of recycled material. And this 3D printing filament we put into the market again. And then you can print again and send us the waste back, and we will recycle. And if you don't need your parts anymore, you can also send it back. And also your empty spools, if you are using spools, you can send us. And we thought it is a good thing to use this also again. And until now, we never bought any spool till now. And it will be a long time then. So customers are sending us their waste, but we thought it is some kind of value on this material. So we developed a reward system like payback, or I don't know what kind of systems are out there. A lot of companies are using it. And you get points for the amount of waste you send us, and it depends on how good is it pre-sorted. So is it sorted just by material, or is it sorted by color? Then we double the points, but it's not necessary. You also get points for your empty spools. And these points you can use as a discount to get new filament, the recycled filament, from us. With this filament, we save 53% of the carbon footprint compared to new material. And this is just PLA. We are calculating at the moment for PETG, and it will be a lot more. So we show that it is really possible to save carbon dioxide by recycling materials, even bioplastics. We use no new material. It is possible to produce fully recycled material. In the beginning, a lot of people say, no, you can't. You cannot do it. But it is possible. And with this, it's also possible for companies to use it as an argument in the CSRD directive reporting. It's coming into the European Union in the next years. It's getting more and more important. So some of you maybe will hear about it in the future. Who is using this? Always a question I will get. So it's companies, small companies, up to bigger companies, private customers, from small to big, and also a lot of different educational institutions. So our filament contains up to 100% waste. Why up to 100%? Because there are also special wishes from customers like, I like especially this color, then we have 1 or 2% of colorant, then it's just 99 or 98% recycled. But it's a lot better than everything else. Also, it's precise and reliable. We have the standard diameters that are available on the market. So most of our customers didn't feel any difference about the material. And it's produced in Europe. We also are looking for additional waste streams. What waste is out there that could be recycled and put into a circular system? For example, these are packaging blisters from hospitals made out of PETG, which we are collecting and recycling into 3D printing filament. So it's possible to add other materials that are maybe one-time use, like in the hospital, into a circular system. I just have written down some facts about our factory. We saved over 200 metric tons of material until today. And it was the amount of the last 4 years. We found 4 years ago, and it will be a lot more in the future. We recycle actually 400 kilograms of waste a day. So it's not even imaginable how much waste is out there, how much is getting into burned somewhere. And it's not just plastics, there are also a lot of more topics we have to think about in the future to be more sustainable in 3D printing. But what now? what are the next steps? I'm always asked, what can you do in the future? How big or how much scale can you do? And now, this year we did something. We thought a lot about, can we do it? Will we do it? We need the right people for it. And it's something new. Nobody knows before. So you're the first I will show today. It's not just recycling fabric in Germany anymore. This is where we started. And in the time of this year, we will go to Turkey. We found the right people that are also into 3D printing and want to do something sustainable, and said, we have to do this in our country, and we will take the risk by building and run the business, because it's a franchise, and we are starting now to build up the structures to get everything running until maybe the end of the year, and then we will show what is next. Because every time you want to move something, you need people that are into the topic, and 3D printing is a topic where people are getting connected. It's a community thing, and we are also coming from this 3D printing community. I'm not a professional recycling guy in the beginning. It was just a hobby, it was just a joke. Let's do this, let's move something to do something sustainable. And that's quite important for the future. So I am now saying a sentence just for you, Janos. One more thing. We are bringing back a product people are asking a long time, a really long time. And today it's going back into our online shop. And I think I have some samples out there. I have to look, but I will give everything I have with me. It's a product of our first hour, where we just throw something into the machine to look what's coming out there, and people loved this product. With the industrial scale, we lost the product, and now we bring it back. It's our Purite unicorn. So the names of the colors are built by our community online. So we are connecting with the people to name our filaments. So we have really funny names like rotten avocado. Yeah, you have to want it. Thank you for listening.
Fantastic. Okay. You ready to go to the next thing? All right. We're running like a well-oiled machine this morning. Well done, sir.
Is co-extrusion in the future? It's difficult in recycled materials because it depends on the waste streams you get. So we do a lot of post-consumer recycling, and you need for co-extrusion exact same parameters for each color, and it's quite difficult to get this.
So the question, if you guys didn't hear it, Daniel asked if co-extrusion was in the future. Fantastic. This was really awesome. Thank you so much for being here. That's great.
Yeah, thank you.
I know that as someone that's been 3D printing 10 years and coming from the States, we don't have nearly enough resources for recycling where we're at, and I think it's going to become more and more critical that we have companies like yours leading the way. So thank you, and hopefully we can go even more international at some point if people will do their part to make sure that they're making your job easier.
Hopefully.
Very good, very good. That was awesome.
Watch our project zoom.